Hi guys, welcome. This is week 3 for 7th grade math. We're going to look at lesson 86, 87, and 88. Again, we're just watching a video for the entire week instead of every day, so hopefully that's even a little bit off for you guys. The lesson 86, jump right in, is looking at number families. So again, number families are way we group numbers. So we talk about all different sorts of numbers, counting numbers or natural numbers, or sometimes referred to as 1, 2, 3, 4, 5. Typically, we don't start counting at -9 or something like that. We start 1, 2, 3, 4. So those are our counting numbers. Whole numbers, nearly identical to counting numbers, we just start with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Integers are whole numbers and their opposites, so 0, 1, 2, 3, 4, 5, all the way on, and their opposites, -1, -2, -3, -4. Okay? Not numbers in between these, that's why it's just the shaded dots on the numbers themselves, because 3.5. 3.5 is rational, but it is not a counting number, a whole number, or an integer. So we can have different subgroups. A number can be rational, but that doesn't mean it's also an integer or a counting number. Rational numbers, it can be written as a fraction. Also, if we do the division of that fraction, it would come out to be either a repeating or a terminating decimal. If it goes on forever, then we can't express it as a fraction, and it's irrational. So pi or the square root of 2 or something like that, there's no way to express it as a fraction, and it goes on infinitely to infinite decimal places. So that's a rational number. So 1/2, 5/3, 3/2, whatever. Those are all rational numbers. Even our whole numbers, 2 can be written as 2/1. So it can still be written as a fraction. So kind of the breakdown, we have counting numbers, and then we go a step beyond that, whole numbers, and then whole numbers and its opposites move us into integers, and then integers, and beyond that, numbers between those integers would be rational numbers, as long as it can be expressed as a fraction. So I can give you the examples. So it says to graph the integers that are less than 4. Well, integers means 3, 2, not 2.5 or anything like that. It's going to be an integer. It's going to continue on. So we don't just put a shaded dot above 3 or an open one above 4 and then just point to the left. That would be incorrect because it doesn't include every number to the left. Obviously, 2.5, as we said, is to the left of 4, but it doesn't satisfy what we're looking for. Graph the integers that are less than 4. Okay, true, false. All whole numbers are integers. And so our whole numbers, 0, 1, 2, 3, 4, 5, are those integers? Yes, so that would be true. All rational numbers are integers. And let's think about that. 1/3 is rational. Is it also an integer? No, so that would be false. Okay, so this is just really some vocab and some terminology review. We've gone over this, I know, more than once, but it's good to review some of the different group families of numbers that we have. Also, we've talked about prime numbers, composite numbers, odd numbers, even numbers. We'll get more into irrational numbers. There's even real and imaginary numbers beyond these things. So this isn't all of the groups, but these are some of the ones we've talked about so far. All right, so lesson 87, multiplying algebraic terms. So if we have 3x plus 2x equals 5, well, this is saying 3x or 3 times x. This is 2 times x, and this is 5 times x. But if we're multiplying, we know adding got to be like terms, same variable to the same power. So this is x, 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 x to the power 1. We can add these up, and we can solve for x. Now, if we're multiplying using the different properties we've talked about, well, 3x times 2x, 3 times 2 is 6. X times x is x squared. So commutative and associative property mean we can multiply and move that around. It's going to give us that number. And so if we look at this one, trying to open physical books, so I'm not having to flip back and forth and make sure I write all that down correctly. So in looking at example 1, we have in the parentheses 3x squared y 2x. Again, these terms in parentheses next to each other, we know that we're multiplying them. So even though we don't have one of our multiplication symbols, we know we are multiplying. Okay, so again, we can multiply in any order. So I can do my -3 times 2 times -4. So -3 times 2 is -6 times -4 is positive 24. And now x squared times x times x, well, x squared times x is x to the power of 3 times x is x to the power of 4. And y times y is y squared. Right, so we get 24 x to the power of 4 y squared. In example 2, we have coefficients and then a and b. So again, if we don't have anything to multiply it with, we don't have anything that's the same base, well, we don't just get rid of it. There's nothing else we can multiply it by. So we're still going to keep it in there. We're not changing, we're renaming this and simplifying it. We're not changing it. 2ab squared b. So we got no coefficient here, but we know it's 1. That'd be -2 times 3, which is -6. A times a squared, and then b times b cubed. Well, b times b is b squared times b to the power of 3 is b to the power of 5. Oh, sorry, this was a squared. See, gotta be careful. A times a squared. I got my hand count, so this would actually be cubed. A times a squared. Again, same base. The exponents we add. We could go through and write out what b times b cubed is, what b times b times b. So we can still do it this way, like off to the side, if that helps us count them up. But if we remember, 1 plus 1 plus 3 is 5. We can apply that rule as well. Or you can say b times b times b times b times b is b to the power of 5. When we get there, there's nothing we can do to simplify it, so we would be, we're not solving. Again, sometimes I've seen you guys on tests, not everyone, but you're putting an equal sign in there and trying to solve for a and b, which we're not doing, and you're making life more difficult just to get the wrong answer. So all we're doing is simplifying this example. All right, now if we have something where we're raising a power to another power, in that case, we would multiply. And so if I have 3xy parentheses squared, we're not just squaring the y or the x, we're squaring all of it. And we'll have to multiply this times itself. And then we'd end up with 9x to the power of 4. Oh, sorry. This is the one down below. That was 9x squared, because we have x squared, y squared, so 9xy squared. Okay, so if I have 3 squared b cubed, and all of that, again, this entire term, we're raising to the power of 2. And it's essentially multiplying this by itself. So 2 squared is 2 times 2. Same thing. This term squared is this term times this term. Okay, so I get -3. Again, I could think of this almost as like distributing this exponent into my entire term, everything I'm multiplying. So -3 squared is positive 9, because -3 times -3, positive 9. A squared squared, a to the power of 4. B cubed squared, in this case I'm multiplying it, don't add them since I'm doing exponent to another exponent. So b to the power of 6. So 9a 4b to the power of 6. That practice set we will do together when we return. All right, and then 88, multiple unit multipliers. Again, unit multiplier is just something that's equivalent to 1 foot over 12 inches, 60 minutes over 1 hour, whatever it is. Use 2 unit multipliers to convert 5 hours to seconds. 5 hours, and then we need to multiply and get rid of hours. So 1 hour equals 60 minutes, but then we want to end up with seconds, so I need to get rid of minutes. So 1 minute equals 60 seconds. So minutes and minutes are going to cancel out hours and hours. And we're going to be left with 5 times 60 seconds equals 18,000, and then I'm left with seconds over 1 times 1, which is just 1. So I'm just leave it at 18,000 seconds. Diego wants to carpet a 16 by 9 foot room, has an area of 144 square feet. Carpet is sold by the square yard. How many square yards of carpet? This is something I've seen people get in a hurry and they do the math wrong, and they're going to end up with way more than they need or not nearly enough. So we want to convert square feet to square yards. Again, feet and square feet are different. If there's just feet to yards, yeah, there's 3 feet in a yard. There's actually 9 square feet in a square yard, and I'll show you why. So we want to get rid of feet squared. And so I want to get rid of feet times feet, or feet squared, so that's why I get 3. So that's why I have to use 2 unit multipliers, because feet and feet are going to cancel out feet and feet. And the 140 times 1 times 1 divided by 3 times 3, which is 9. So 144 divided by 9 is 16, and then yards times yards is square yards. So if I just did 144 and I said, oh, feet and yards, I know how to convert those. Divide by 3, you would have got 48. Well, if you buy 48 square yards of carpet, you only need, correctly, 16 square yards. You're going to have way more than you need. Hopefully they have a good return policy. So 16 square yards. Let's look at, as Tina approached the traffic light, she slowed to 36 kilometers per hour. Convert kilometers per hour to meters per minute. So what we write is this. We want to end up with, so I always start with what we're given and what we want to end up with. That kind of helps me work backwards to figure out how I'm going to convert that. So we have kilometers per hour, and we want to end up with meters per second. All right, so I want to get rid of kilometers. So I know there's 1 kilometer is 100 meters. That's good. And then I want to get rid of hours, and I could do this the other order too. So 1 hour, 60 minutes, hours and hours, kilometers and kilometers. I'm going to be left with 36 times 100 divided by 60. And I do 36 times 100 over 1 times 1 times 60. So 3,600 divided by 60 gives me 60 meters over 1 minute. 36 kilometers an hour is the same rate of 60 meters per minute. Oh, wait. I think I missed a 0. centimeters. Sorry, 1,000 meters, 1 kilometer. Okay, so within 36,000 divided by 60. 600. Okay, double check your work. So there's 1,000 meters in a kilometer. I think I said 100, but there's 1,000. Again, you can check your reference sheet. This is where sometimes they'll give it to you in parentheses in the actual problem, but okay, yeah, it didn't give us that. Oh yeah, it did. 1 kilometer is 1,000 meters. So, but if it doesn't, that's why I give you your reference sheet, and you guys can use those. All right, so we will do that practice set together and continue on, and that'll be it for this week. See you guys in class.